4.1 is on congruent figures, and we want to recognize congruent figures and their corresponding parts. Just like if you were putting together a puzzle, you would try to find congruent figures. In other words, the shape that goes into this puzzle piece, we want to find the exact same shape. So we want it to look exactly the same. So we would pick shape 1, I think, to go in there, because shape 1 and shape A are congruent to each other. And that's kind of what we're doing today. So typically I have kids come up and do this part where we say, are these figures congruent? And so if you look at these two are the same shape, but if you look, you have to make sure the exact same size. And even though they didn't really look the same size, I don't think, when they were apart, you can see that they are. So these two are congruent figures. When I put them over each other, they line up exactly. And again, we can try these all out and see. Are these two congruent? Can I get them to line up exactly? Yep, so those two are congruent. Are these two? No, they're not congruent, right? One is smaller than the other. And how about our triangles? If you look at our triangles, they are not congruent either because one is smaller than the other. So we have two sets of congruent figures and two sets that are not congruent. So what makes a congruent figure? Well, congruent polygons have congruent corresponding parts. In other words, their sides and angles are congruent. So congruent sides and congruent angles. When you name their congruent polygons, you must list the corresponding vertices in the same order. So if I look at this, it says ABCD is congruent to EFGH. And we look at these two pictures, and if I ask you what AB is congruent to, hopefully you're going to say EF, this short little top part, and that short little top part. And then I look at ADC, angle ADC, which is right here. And which one on the purple figure does that line up with? Well, I don't even have to look at the purple figure, honestly, and I don't because I think it's more confusing than not. I look at the congruency statement, and I look at here where I said AB, those are the first two things listed, has to be congruent to EF because it's the first two listed, and order matters when you list it on in the congruency statement. So then it says angle ADC, so angle A, that's the first number, D, we picked the second, and 3. So I have to go in that same order. I don't use this one at all. So I need that, the same order, so I need angle. The first thing I listed here was A, so the first thing over here is E. Then we jump to the end with the D, so I have to jump to the end with the H. And then third, we need the G. So EHG. So EHG. Now, I usually have kids that will tell me, wait, that's not congruent, Mrs. Carlson, because if I turn this, is it going to turn everything? And line it up. Remember we said so we had that marked congruent to that, and then we had EHG. So EHG was this angle, right? And they'll say that's not the same angle, but you have to remember I don't only, excuse me, I can't just turn these shapes, I could flip them too. So if I take the purple shape and flip it over, because right now it's symmetric with the red shape. So imagine picking that shape up and flipping it over onto the other one. H would then line up with D. So they're congruent, but they're the one is flipped over. So I would need to actually flip it and turn it. So that's why I think it's so much easier to just go by the congruency statement where it says. So here it says suppose triangle WYS is congruent to triangle MKV. If measure of angle W is 62 and Y is 35, what's V? And explain it. Well, I would say draw a picture. I don't like to do this without having something to look at. I have my two triangles. And WYS is congruent to M. I'm going to name them and do it in the same order. KV. And W is 62. And Y is 35. And it wants me to find V. Well, how am I going to do that? I'm going to pause for a second because hopefully you're figuring it out. And hopefully you would have come up with the fact that if those two are congruent, and I know in the first triangle that we have 35 and 62 degree angle. I know that this one, I think it's 83 because I have to add up to 180, right? So 35 and 62 is 97. So the other one has to be 83. Well, if they're congruent, it says way up here that S is going to be congruent to V. So if S is 83, then V also has to be 83 degrees. So again, pictures are a good idea. See if triangles are congruent, we have to look at their parts, and we have to make sure all the angles on all of the sides are congruent. So are these triangles congruent? And justify our answer. There's only a few things you can assume in geometry. If it looks like a line is a line, so we can do linear pair. We can also do vertical angles. So if I look at this picture, I see there's a set of vertical angles. So I can automatically mark those as congruent. So are all the sides and all the angles congruent? Well, I have a side that's 4. So BC is congruent to DC. And we know that, yeah, and we know AC, so is 6 units long, and it's congruent to EC. And I know the other one, I don't know the side length, but it says BA or AB is congruent to DE because of how they're marked, right? They each have a single hash mark. And you notice I did BA going in this direction. I started where there was 2 arcs in the angle and went to the one with 1. So over here, I'm going to start where there's 2 arcs and go to the 1. So since I did BA, I know I have to do DE. So I have all the sides are congruent. And if you look, we have all the angles marked congruent too, right? Angle A is congruent to angle E. Angle B is congruent to angle D. And then the third one we can't name just by a letter, but we can say angle CBA is congruent to angle, I started with C, so I'm going to start with C again. I went to B, which has 2 hashes, so I have to go to D, and then CDE. So all the sides and all the angles are congruent. So we know that the 2 triangles are congruent. How do we, are these 2 triangles congruent, and justify your answer here? So here, what do we know? I know AD is congruent to CD. And a lot of times kids will tell me AB is congruent to CB. But how do I know that? Do I know that for sure? Do I know that that line comes down exactly in the middle? It's not marked that it's in the middle. It's not marked that it's perpendicular. I do know one other thing. If I'm looking at this triangle and this triangle, I know they share a side. So I know DB is congruent to DB. And why can I say that? Because of reflexive property. But that's the only 2 things I know for sure, right? I don't know any of the angles are congruent. You know, right now I don't. At some point we will know, because this is an isosceles triangle, so I know their base angles are congruent. But so far we don't know that. But even if we did, that's one of the 3 angles. We don't have the other ones. We don't have the other side. So we can't justify the fact that they are congruent. So we don't know if they're congruent. All right, we have a theorem called the third angle theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Which makes total sense because I have to add up to 180, right? So if two of them are the same in one triangle, and you subtract that value from 180, then you subtract the same value from 180 on the other triangle, they're going to be the same. So if you know two triangles are congruent, we know then the third triangle is congruent. That's third angle theorem. All right, let's prove these two triangles are congruent. Given all of that information, we want to prove these two triangles are congruent, the top and the bottom triangle. So first statement says LM is congruent to LO. Well, that's a given. And it's also marked already, LM and LO, so it is marked already for us. MN is congruent to ON, which is also marked. So why do we know those two things? Because they're given. LN is congruent to LN. That isn't given. Why can I say LN in the top triangle is congruent to LN in the bottom triangle? Well, it's one line. It can't change shape partway through. So it's in both triangles. They share it. But anytime we have something congruent to itself, it's a reflexive property. And in this case, it'd be of congruence or of congruency. Angle M is congruent to angle O. Angle MLN is congruent to angle OLN. Those are both given. Feel free to pause and do these on your own without me blurting all the answers out. And then it says, hey, this angle is also going to be congruent to that angle. Well, why can I say that? Well, maybe just learned it. So right here we learned the third angle theorem. That says if two angles are congruent, which they are already marked, then the third angle has to be congruent. So third angle theorem. That's a really messy theorem. So third angle theorem says that if two angles are congruent in one triangle to two angles in another triangle, the third angle is also congruent. Now I've marked every single side and every single angle in both of those triangles as congruent. So this is just, why can I say they're congruent? Because that's the definition of congruent triangles. It says all their sides and all their angles are congruent. So let's look at another one. Given angle A is congruent to angle D, and AE is congruent to DC, and EB is congruent to CB. We got lots of given. BA is congruent to DBD. All right, so it looks like they already marked all of that for us in the triangles. So again, we have to show every single side and every single angle are congruent to prove the two triangles are congruent currently. All of our sides are done. They have 1, 2, 3 all marked the same, but I only have one angle. So again, there's a couple of things you know by looking, and we know vertical angles are congruent. So I'm going to say angle ABE is congruent to angle DBC. ABE, I went past the 3, AB, so I have to start and go past the 3, so it's DBC. All right, so those two angles are congruent, and then we just learned, and this was reflexive property. Sorry, I should have given here. And this is reflexive. And then we learned third angle theorem that says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So that gives me angle E is congruent to angle C. And now we have all the angles, all the sides congruent, so I can say triangle AEB is congruent to triangle DCB. And why can I say that? It's just the definition of congruent triangles. We don't usually use that reason because we have shortcuts that we'll talk about tomorrow, but right now, once you've proven everything's congruent, that's all you have to do. So that is it for this. You just have to write down your homework and then you are good to go.